Launching into combat just 27 months after its maiden flight, the LTV A-7 Corsair II set a record for the fastest deployment of an aircraft into battle. Entering the fray in the mid-1960 SS as a rambunctious state-of-the-art attack aircraft for the U.S. Navy, it quickly proved its mettle in the skies of Vietnam, becoming the war's most successful tactical jet bomber. With a smaller size and less glamorous appearance than some of its flashier contemporaries, the A-7 would become affectionately known as the short little ugly fella, or SLUF. Yet its unassuming visual profile belied its extraordinary capabilities, its pioneering use of a heads-up display, sophisticated digital navigation combat system, and computerized weapon aiming allowing for pinpoint accuracy and bomb delivery. Fundamentally altering the landscape of ground attack missions and setting a precedent for future generations of military aircraft. The A-7 Corsair II, renowned for its impressive range and endurance, mastered the skies with a payload capacity that seemed limitless. Equipped to deliver destruction with surgical precision, it handled a broad spectrum of missions, from laying sea mines and launching anti-ship strikes to executing armed interdictions and providing close air support. Celebrated as the ultimate bomb truck, the Corsair II was a powerhouse of versatility, capable of adapting to any combat scenario thrust upon it. In an era dominated by the quest for speed, the Corsair simply did what supersonics couldn't. In the early 1960s, as the pressures of the Cold War arms race demanded constant innovation, the United States Navy started looking into replacing the Douglas A-4 Skyhawk as its principal light attack aircraft. Although the A-4 would in fact stay in production until 1979 at the time, many believed its days were numbered and pushed for the creation of a more advanced attack platform that would fly at supersonic speeds, carry heavier payloads, and fly longer distances. In December 1962, the Sea-Based Airstrike Forces Study Group analyzed performance and cost for various aircraft concepts, scrutinizing 144 different hypothetical aircraft models before coming to a surprising but firm conclusion. A subsonic aircraft could outperform its supersonic counterparts. By opting out of supersonic speeds, the resulting aircraft design could be more compact, cost-effective, faster to develop, and simpler to produce, meaning more units could be made. Rather than focusing on velocity, the investigation suggested enhancing the precision of weapon delivery to minimize the cost of munitions per target. With these findings in mind, in May 1963, the Navy issued a requirement for a new type of aircraft, dubbed VL, an abbreviation of Heavier Than Air, Attack, Light. Keeping expenses in check, the Navy stipulated that all submissions should build upon existing aircraft models. This led major aviation players like Vought, Douglas Aircraft, Grumman, and North American Aviation to throw their hats into the ring, each beginning work on a new project based on one from their current roster. With the proposals submitted and the evaluation process complete on February 11, 1964, victory was awarded to Vaught's design, which drew inspiration from their highly successful F-8 Crusader. By March 19th, Vought had secured a Navy contract to start producing the initial series of what would become the A-7 aircraft, gaining the official name Corsair II the following year. This was a nod to Vaught's illustrious history of manufacturing aircraft bearing the Corsair name. While this stretched all the way back to their O-2U Corsair biplane of the 1920s and their SBU Corsair scout bomber from the 1930s, Vaught's latest design was intended as a successor to their legendary fighter bomber F-4U Corsair, which had stood out during World War II and the Korean War, establishing a direct lineage in its role as a ground attack aircraft. While the A-7 borrowed aesthetically from the F-8 Crusader, it also had some notable differences. Firstly, its body was shorter, measuring 46 feet, 1.5 inches, compared to the Crusader's 54 feet, 3 inches. It was also wider and had a more rounded nose, lending the aircraft a somewhat stubby appearance that led to its short little ugly fella nickname. With a span of 38 feet, 9 inches, the A-7's wings were not only around 3 feet broader than those of the Crusader, but they also had a gentler sweep. Both of these elements would contribute to better lift characteristics at lower speeds, enhancing the aircraft's maneuverability and control during such operations, as well as improving its loitering capability, allowing it to remain over the battlefield for extended periods. The Corsair used conventional ailerons located on the outer sections of the wing, providing more predictable roll control during low-altitude attack runs than the drooping ailerons used by the F-8. And the wings were also equipped with large slotted flaps on their inner sections, increasing their area and changing their camber. This improved the lift during takeoff and landing, particularly useful for operations from shorter runways or aircraft carriers, where enhanced low-speed lift is crucial. What's more, the wings could fold upwards thanks to a mechanism located between the flaps and ailerons, reducing the space required for storage and movement on crowded flight decks. The leading edge of the wing was stationary and featured a distinctive dogtooth design, which would help delay the onset of aerodynamic stall at high angles of attack, improving the wing's aerodynamic efficiency and control authority at low speeds and during high-G maneuvers, which are typical in attack and bombing runs. These wings were equipped with 6 pylons capable of carrying up to 15,000 pounds of a diverse array of weapons, including conventional bombs, guided missiles, and, later, precision-guided munitions, making the Corsair highly versatile and effective in various combat scenarios. As the A-7's design emphasized payload capacity and low-level bombing accuracy, it was decided to do away with the F-8's variable incidence wing mechanism in favor of a fixed wing which would support these requirements more directly. Like the Crusader, the Corsair had fully powered flight controls, meaning that the pilot's inputs to the control stick and rudder pedals were boosted by hydraulic systems, enhancing the aircraft's responsiveness and reducing pilot workload, especially important during high-speed flight and complex maneuvers. For improved aerodynamic braking, a large air brake was mounted on the aircraft's underside. The Corsair's landing gear, consisting of a 3-unit assembly, retracted into the body, with the front gear being a steerable twin-wheel setup designed to withstand the forces of catapult launches. Where the F-8 had used an afterburner-reliant Pratt & Whitney J57P28 turbojet engine, the A-7 was designed to operate at subsonic speeds, so an afterburner was not necessary. Instead, it was equipped with the Pratt & Whitney TF30P6 turbofan engine, which delivered 11,350 pounds of thrust and was also used in aircraft like the General Dynamics F111 Aardvark and early versions of the Grumman F-14 Tomcats. As the A-7 evolved, it transitioned to more advanced engines due to the original power plant's production challenges, compounded by high demand from both military and civilian sectors. These newer engines included the Pratt & Whitney TF-38 and the Allison TF-4102, a licensed version of the Rolls-Royce Spey engine known for addressing the early A-7 model's issues like compressor stalls and insufficient thrust. When it came to armament, apart from its sizable payload, the Corsair was originally fitted out with 2 cannons on the underside of its nose. In later versions, these were upgraded to a single, more powerful M61A1 Vulcan, a 6-barrel, air-cooled, electrically fired Gatling-style rotary cannon that could fire at an impressive rate, making it highly effective for strafing runs and air-to-air combat. The A-7 could also carry AIM-9 Sidewinders fire-and-forget missiles that could seek out the heat signature of enemy aircraft, making them highly effective in dogfight situations. These were mounted on both sides of its fuselage for rapid engagement with enemy aircraft. Understanding the risks posed by ground-based enemy fire, the A-7's design included significant protective measures. Its hydraulic systems for flight control were tripled, ensuring redundancy and reliability even under fire. Other critical systems were doubled for the same reason. Additionally, key areas of the fuselage were reinforced with armor, reducing the aircraft's vulnerability to damage and ensuring the pilot's safety during low-altitude operations. Yet the Corsair truly came into its own through its use of state-of-the-art systems. The AN/APQ-116 radar was designed especially for the A-7, while later versions upgraded to the AN/APQ-126, seamlessly integrated with the ILAS digital navigation system. This advanced radar setup was linked to an IBM navigation and weapons delivery computer. enabling the A-7 to drop bombs with high precision from increased distances. This capability significantly enhanced the aircraft's survivability, especially when compared to faster jets like the McDonnell Douglas F-4 Phantom II, which had to get closer to their targets for bomb delivery. A notable first for the A-7 was the inclusion of a modern head-up display, or HUD, crafted by Marconi Elliott. This HUD projected vital flight information such as dive angle, airspeed, altitude, drift, and the aiming reticule directly in the pilot's line of sight. This feature, now commonplace in military aircraft, was a significant innovation at the time. Another example of pioneering technology used by the Corsair was the Projected Map Display System, or PMDS. Providing a real-time projection of the aircraft's location over two different map scales greatly enhanced the pilot's navigational accuracy and situational awareness. The A-7 also boasted data link capabilities that enabled hands-off carrier landings, a feature made possible through its approach power compensator or auto throttle, streamlining the landing process and enhancing safety. Below the radar screen, pilots had access to an innovative projected map display, which was linked to the inertial navigation system. This display offered a detailed map, showing the aircraft's current location over standard navigation charts, providing unparalleled situational awareness. Additionally, the A-7's advanced inertial navigation system could autonomously navigate to up to 9 predefined waypoints, thanks to its integration with the all-axis autopilot. This hands-off flying capability reduced pilot workload and improved mission efficiency. The system's accuracy was top-notch, with minimal inertial drift in new models, and it could be updated through various means, including flyover, radar, and take-in updates, ensuring the aircraft's precise navigation and positioning throughout its missions. The A-7 took to the skies for the first time on September 27, 1965, with a swift and smooth flight test program. Despite some naval officials advocating for a slowdown to further enhance the A-7's avionics, the push to quickly deploy the aircraft prevailed as American involvement in Vietnam rapidly increased. By October 14, 1966, the Navy had received enough A-7s to establish the first squadron, which reached operational readiness by February 1, 1967, and entered combat in the Gulf of Tonkin by December that year, representing one of the shortest turnaround times from first flight to combat deployment of any aircraft in history. However, the Corsair's participation in the conflict was not limited to Navy use. Under pressure from the U.S. government and Army, who believed a subsonic aircraft like the A-7 would be best equipped to provide troops with air support, the U.S. Air Force ordered their own modified version in November 1965, designated A-7D, which would enter service from 1970. Impressed by the upgrade, the Navy responded with their own new version, the A-7E, gradually replacing their already existing A-7A, A-7B, and A-7C models in Vietnam. Throughout the war, the Corsair proved itself as a highly effective addition to both military branches, its precision strike capabilities allowing for more effective and efficient use of ordnance, reducing collateral damage and increasing mission success rates. In one particularly notable Navy mission on October 6, 1972, 4 A-7Cs from Attack Squadron 82 effectively dropped 8,000 pounds of high explosives on the Tan Hoa Bridge. 2 of the Corsairs were equipped with 22,000-pound walleye-guided bombs, while the other 2 carried 2,000 pounds of MK-84 general-purpose bombs. Their coordinated strike successfully hit and damaged the center piling on the bridge's west side, breaking it in half and causing its subsequent removal from the military's list of active targets. The following month, the Corsair would again be in the spotlight for actions near Tan Hoa, this time with the Air Force. On November 18, 1972, Major Colin A. Clark led a critical combat search and rescue mission in the area to save the crew of a downed Republic F-105 Thunder Chief. The operation extended over 8.8 hours, during which Major Clark and his wingman came under intense .50 caliber anti-aircraft fire. In recognition of his leadership and bravery in coordinating the successful rescue, Major Clark received the Air Force Cross, while his A-7D was later placed on permanent display at the National Museum of the United States Air Force, located at Wright-Patterson AFB in Ohio. The USAF A-7D completed 12,928 combat missions in the Vietnam War, suffering only 6 losses, one of the lowest rates of any American aircraft during the conflict. In terms of bomb delivery, the aircraft ranked second only to the Boeing B-52 Stratofortress for the total volume of ordnance dropped on Hanoi. It also achieved higher bombing accuracy and dropped more bombs per mission than any other U.S. attack aircraft. After the war, the Air Force initiated the process of transferring its active-duty A-7D aircraft to Air National Guard units. In 1989, A&G Corsair squadrons would expend 2,715 rounds of ordnance in the U.S. invasion of Panama, having been training with Army and Naval forces defending the Panama Canal. Meanwhile, the Navy held onto its A-7Es, and they would frequently participate in U.S. operations throughout the 1980s and early 90s, such as the invasion of Grenada, conflicts in Lebanon and Libya, and Operations Desert Shield and Desert Storm before the last fleet operational squadrons were finally retired in May 1991. The A&G retired their last Corsairs 2 years later. Elsewhere, however, the Corsair would continue to roam the skies, finding new homes in the air forces of Portugal, Greece, and Thailand, while a bid from Pakistan to buy 110 A-7S from the U.S. in 1976 was rejected for fears of intensifying their arms race with India. When Greece withdrew its final Corsairs from service in 2014, it marked the end of a 49-year career. The LTV A-7 Corsair II may not have been the fastest or most elegant bird in the sky, but its near half-century of service stands as a testament to its impressive versatility, survivability, and reliability.